Hey everyone, welcome back to my YouTube channel. So in today's video, we'll be solving the last 5 questions of this paper. So let's begin. In the pentagon ABCDE, all right, angle ACB, angle AED are both 90 degrees, which is shown by this little square. So they're right angle triangles. Now triangle ACD is equilateral, right, with side length 12 centimeters. That simply means that it has the same side length and the same angles, right? So DE and BC are both of length 6 centimeters. So they're asking us to find the angle BAE, this angle right here, right? But how are we going to get that? We're going to have to break it down. So let's start by finding first the angle that's right here, okay? Then we're going to try to find the angle that's in the middle. And finally, we're going to find the angle that's right here. Okay. Once we have those separate angles, we can add them up and we'll get the final answer. So we all know about SOHCAHTOA, right? Sine, cosine, tangent, right? So we're going to use that. Now, let's find the first one, angle BAC. You'll notice that we have the opposite. So this is the length that's opposite to this angle, right? And we have the adjacent. So this is the length that's adjacent to this angle, not the hypotenuse, because the hypotenuse is opposite to the 90-degree angle, right? So if we have the adjacent and the opposite, that means we're going to use tan. So tan theta is opposite divided by adjacent. We want to get theta alone, which is the angle. We're going to move tan to the other side. So tan inverse of 6 divided by 12, or tan inverse of half, will give us 26.565 degrees, right? So we found the first one. Now the second one's a little bit easier, right? Because angle CAD would be 60 degrees, simply because the interior angles of a triangle must make 180 degrees. And since it's an equilateral, meaning it has equal sides and equal angles, so we can make use of that. So 180 degrees, divide that by 3, which is the 3 sides that we have, will give you 60 degrees. So 60 plus 60 plus 60 will end up giving us 180. Now finally, the last one, we are given the opposite, okay, and the hypotenuse, not the adjacent. We don't know what this side length is, but we do know what the hypotenuse is. And in this case, it is 12 centimeters. So we make use of that, and that would be sine, which involves the opposite and the hypotenuse. So sine inverse of 6 divided by 12, or sine inverse of half, is 30 degrees. All we have to do now is add them up, and we get around 116.565 degrees. I'm going to just round that up to 1 decimal place, and we know that 6 is greater than 5, so this 5 right here is going to round up. Alright, so let's move on. We're told now to calculate the length AB. So this one right here that we didn't know about before, right? So what we're going to use is the Pythagoras theorem. Now, with the Pythagoras theorem, it involves all 3 sides of a right angle triangle, okay? Now, what's missing is the longest side, which is the hypotenuse, right? So in order to find the hypotenuse, we take the square root, okay? And we're going to do this side length plus this side length, and we're going to square them. So 6 squared plus 12 squared, and then the square root of that will give us 6 root 5, which in our calculator is about 13.416. Again, I'm only keeping it to 1 decimal place, so 13.4. Now we're asked to calculate AE. Again, we're going to use the Pythagoras theorem. AE is the one right here. This time it's one of the side lengths. It's not the hypotenuse, right? So what we're going to do is subtract. So it's the same thing, but this time it's 12 squared, which is the hypotenuse, or the longest length, minus 6 squared, which gives you 6 root 3, which is about 10.392. Again, I'm keeping it to 1 decimal place, so it's 10.4 centimeters. So what you'd like to do when they don't tell you to how many decimal places you should leave it or to how many significant figures, I suggest leaving it to 3 significant figures. And if there are decimals, then leave it to at least 1 decimal place, just because we don't want to lose those marks. And if you are going to keep it whole, at least here, keep it as, in decimal place, so they just see that, oh, she actually did round, she or he or whomever did do their work and didn't cheat off of someone else, right? Okay. So finally, we want to calculate the area of the pentagon. So we're going to break it down again. So triangle ABC, which is a right angle triangle, is going to be half times the base times the height. It's the rule for finding the area of a triangle. So the base is 6, the height is 12, multiply it by half, which will give you 36, right? We want to find triangle ACD. Now, triangle ACD, there is a rule or a formula you can follow, which is half times the two sides times the angle, times sine of the angle, right? Or you can actually just place a line right here. So I'm going to do that right now. And what do you notice? It becomes a right angle triangle. So you can have two right angle triangles with the same area. So you can, find the area of one of them and then add them up. So the base would be here 6 and the hypotenuse would be 12. So you'd have to find the height, which is more work, and we honestly don't need to do that. So we're just going to use the formula that we have, which is half times the side A times the side B times the sine of the angle, which is 36 root 3. I'm going to keep it as that because I don't want to deal with a bunch of decimals. Now, the triangle ADE, which is again a right angle triangle, we're going to have half times the base times the height, which is the one that we found. It's not 12, so just be careful with that. It is 6 root 3. So we multiply that, it gives us 18 root 3. Add that all up in your calculator, you get 129.531. Again, I'm going to leave it to 1 decimal place, so 129.5 centimeters squared. Easy 4 marks. All right, so part B. The diagram shows a cuboid. AB is 8 centimeters in length, BC is 4 centimeters, and CR is 5 centimeters. Now write down the number of planes of symmetry of this cuboid. We have 3. So you can cut this cuboid in half right here, right? This place. So you'd have this top part and this bottom part, and they're going to have the same area. Or you can cut it off like this. So this one side and this side will have the same area. Or like so, right here. I just drew it to the side, but it's the same idea. You'd have it right there. But yeah, it'll give you the same area. But when you're dealing with a cube, for example, you're going to have 9 planes of symmetry because you can consider diagonals, but in the case of a cuboid, you cannot. So what I suggest is creating your own cuboid at home and then cutting it up and seeing which parts are similar, which are not, or you can watch videos, because that will help us retain that information, especially if you're a visual learner. Okay. And of course, when you go into 12th grade, you understand that one is the XY plane, something else is the YZ plane, and so on, which is, nice to know. Okay, so you're told to calculate the angle between the diagonal AR, okay, so AR, and the plane BCRQ, BCRQ. Now, be careful because we are dealing with 3D images, right? So BCRQ is over here. Okay, maybe I'll use a line instead because this is not the best. All right, so this is it. So it's this one right here, okay? So I just tilted the cuboid to the side, so that's why it's at the bottom like so. But anyways, we want to find this angle that's between AR and this plane. So I drew out AR, and here's the plane. We find this angle, right? So if you want to find this angle, I just simply created a line right here between B and R, and we have to find the angle that's right here, which is right underneath this A. So if I drew a line, okay, so if I drew a line between A and B, it would be a right angle triangle. So I'm going to create that little box. Okay. Let me just copy that for the 3 sides. It is a little bit harder to deal with 3D images. It just takes a little bit of time to really wrap your head around it. But once you do, it is pretty easy. So we have this right angle triangle like so. So in order to find this angle, we need to find AR and BR. Or we can use AB, okay, and BR, or AB and AR. Doesn't really matter, whichever one seems easiest to you. We already know what AB is, and that is 8 centimeters, so we only need to find one or the other and use SOHCAHTOA, which is the sine, cosine, tangent thing. So let's find length BR. Now in order to find BR, you'd notice that we formed another right angle triangle. Here's the 90 degrees, here's the hypotenuse, here are the 2 sides. So this one is simple because we already know what BC is, and that is 4 centimeters. We know what CR is, which is 5 centimeters. Place that into our Pythagorean theorem, and we get root 41. So we can continue from here, and we can find R. Well, it's not really R, but this angle right here. So we have the adjacent, and we have the opposite, so you can use tan inverse and get your answer. Or you can try to find length AR. In order to find AR, that would be AC and CR. So I'm going to just create another line so you'd know what that is. But of course, that's just more work. There's no need to do that, which is something I did not realize until I started this video, which is a good thing because there's no need to do all that extra work. So here's your triangle, ACR, and this would be a right angle triangle. Okay? So in order to find AR, we do these 2 sides, which is AC and CR. AC is one we can find, which is BC and AB. So let's find AC first. AC uses AB like we said, and BC, which is 8 squared plus 4 squared, and the square root of that, which is 4 root 5. And then we have 4 root 5 squared plus, so that's AC. I'm going to just keep it there, fine. Plus CR, which is 5. So 5 squared gives us root 105. That was a lot of unnecessary work, so be careful. We can all fall for that, but it's just best not to. So let's find angle ARB. So what do we have now? We have BR, which is the adjacent of this angle. I'm going to move this away. We have the hypotenuse. So adjacent and hypotenuse, that involves cosine. So cosine inverse adjacent, which is root 41, divided by the hypotenuse, which is root 105, gives us 51.33 degrees. Again, keeping it to 1 decimal place, so 51.3 degrees. All right, so let's move on to question 7. Water flows through a cylindrical pipe at a speed of 8 centimeters per second. The radius of the circular cross-section is 1.5 centimeters, and the pipe is always completely full of water. So we know the volume is not a weird one. It's simply a circle or a cylinder. Now, calculate the amount of water that flows through the pipe in 1 hour. Give your answer in liters. Okay. So liters shouldn't be something that is too new for you, but if you don't know, 1 liter is 1,000 milliliters, and we know that 1 milliliter is the same as 1 centimeter cubed, okay? So we'll talk about that again later. So first things first, we're going to find the area of the circle, okay? So area of the circle is pi r squared. We know the formula. R, which is the radius, is 1.5. So 1.5 squared is 2.25 times pi. I'm going to keep it as pi because I don't want to deal with a lot of decimals, and it's just neater that way. Okay, so we move on. So volume is measured in centimeters cubed, right? So how do we get there? We know that centimeter squared times centimeter is centimeter cubed, just like x squared plus x squared times x is x cubed. Here there would be a 1, but we don't really write the 1. And when we multiply something with the same base, which in this case is a centimeter, we're going to add the powers. So 2 plus 1 gives you 3. Now, where can we get that extra centimeter? You'd notice we can get it from the rate, which is 8 centimeters per second. So we're going to take the area of 2.25 pi centimeters squared times 8 centimeters per second. So that will give us 18 pi centimeters cubed per second. Now we know how to find the area of a cylinder, and that is, or sorry, the volume of a cylinder, and that is the area of the base times the height. We don't have the height, so this is the method that we have to use. So we move on. This, okay. So we have 18 pi centimeters cubed per second. However, we don't want it per second. We want to know in an hour. So what we can do is something that's, I'm not sure what the name of it is, but it's this method right here. So we're going to multiply by 60 seconds per minute. We know there's 60 seconds in a minute. You can always switch it around. You can say in a minute there's 60 seconds. So the 60 seconds could be at the bottom. But in this case, we want it in the top. And why? Very simple reason. Okay, I'm going to change the color first. You notice, oh my. Okay, so this second right here will be crossed out. I'm going to copy this one because it's a little easier to deal with. Okay, so this second right here is going to be crossed out by the second on top. Like I told you before, 5 divided by 5 is 1, 3 divided by 3 is 1. So second divided by second is 1. And if you multiply anything by 1, it stays exactly the same. Now, we have centimeter cubed now per minute. We don't want minutes, so again, we're going to do the same thing. So there's 60 minutes in 1 hour. So we're going to get rid of this minute and this minute. So that way, you'll realize, what do we have at the top? We only have centimeter cubed at the top and hour at the bottom. So we're going to multiply 18 pi times 6 times 60 times 60 gives you 64,800 pi centimeter cubed per hour. Now, we don't want it in centimeter cubed though. We do want it in hour. And like I told you before, 1 liter is equivalent to 1,000 milliliters. And milliliters and centimeter cubed are equivalent to each other. So we can use that information. Again, using this similar method, 64,800 pi centimeter cubed per hour multiplied by 1 liter, right? In a liter, there's 1,000 centimeter cubed. Now, in this case, centimeter cubed at the bottom because, well, we want to get rid of the centimeter cubed. So I'm going to just copy, paste. Okay, so we have centimeter cubed right here. That's gone. There you go. What do we have left? We have liter at the top, okay, and we have hour at the bottom. So then when you multiply, you get 324 divided by 5 pi liters per hour. Now they told us the answer for 1 hour. So if you place that in your calculator, it is about 203.6 liters. If they asked us for 2 hours, we'll simply multiply this value by 2. If they asked us for half an hour, multiply it by 0.5, and so on. So that's it for question 7a. It is a lot, but once you wrap your head around it, it is pretty simple. Alright, so part B. The diagram shows 3 solids. The base radius of the cone is 6 centimeters and the slant height is 12 centimeters, okay? The radius of the sphere is x centimeter and the radius of the hemisphere is y centimeters. So this is y, x, and so on. The total surface area of each solid is the same. Okay, this is important. Now, show that the total surface area of the cone is 108 pi centimeters squared. Now, see, even if you didn't figure out how to solve this, they already gave you the answer. So during an exam, you can move on and try to solve the other parts and then come back to this because you already have the correct answer. Now, we just have to prove it. So the curved surface area of a cone with radius r and slant height L is this, right? This is the formula. So let's do that. Area of the curved surface, right, pi r L, is pi times the radius times that slant height, which is 12. That gives you 72 pi. But we're not done. This cone does have a base, right? So it's not like an ice cream cone that does not have a base at all. This one does. So in this case, we also have to find the area of the circle. So we already know circle is pi r squared. So pi times 6 squared is 36 pi. So total surface area is the addition of both, which is 108 pi centimeters squared. So make sure to place centimeters squared at the end because, you know, it's always important to place the units and everything. Okay. So find the value of x and the value of y. So the value of x is pretty simple, which is through this formula we can find. So we know the area of all the shapes are the same, which is 108 pi, is equal to, they told us, 4 pi r squared, which is the formula for finding the area of a sphere. R in this case is x. We don't know what it is. We're going to solve for x. So 108 pi, we're going to move this 4 pi to the other side. So we're going to do the opposite operation. So here it was multiplication. So on this side, it's going to be division. So 108 pi divided by 4 pi. The pi's cancel out. So we'll end up with 27. Now, if we want x alone, we're going to take the square root of 27. And that would be 5.196. I'm going to round it to 2 decimal places because in this case, it will give us 3 significant figures, which is 5.20. All right, so let's find y. The total surface area of a hemisphere is the curved surface area plus the base area. In this case, because the base is also there, right? So it's not like volume. So what we're going to do is the curved surface area is half of a full sphere, right? So 4 pi r squared divided by 2 will just give us 2 pi r squared, right? But r in this case is going to be substituted for y in this case, right? So 2 pi y squared plus the base area, which is the area of a circle, pi y squared, or pi r squared, but it's because we're going to place y in this case. So you add that together, it gives you 3 pi y squared. And we know, if this confuses you, think about 2x squared plus x squared. That would simply give you 3x squared, right? So we're going to add the coefficients. Now we're going to move 3 pi to the other side. So 108 divided by 3 pi is y squared. That will give you 36. So the square root of y is 6. One thing to keep in mind is that although negative 6 times negative 6 gives you 36, or negative 5.20 times negative 5.20 will give you that 27, we have to ignore it because you can't have a negative surface area. So it all depends on the circumstance, it all depends on what you're working with. So the final answer has to be positive, and that is 5.20 and 6. Okay, so on to question 8. So we have these matrices. M has a dimensions of 2 by 2, so row by column. So we have 2 rows, okay, 2 columns. N has 1 row and 2 columns, so it's 1 by 2. P has 2 rows, but only 1 column, right? So it's a 2 by 1. So when we're naming or giving the dimensions of the matrices, it's in the order of row times column. Okay, so for the following calculations, put a tick if it's possible, or put a cross if it's not possible. There is no need to carry out any of the calculations. So this is really kind of them to tell you, because I know some people would probably actually try to go through each one, but this is something you should know. So let's try this. N plus P. So can we add that? That's not possible, because when you're trying to add matrices, they have to have the same dimensions. So I added the dimensions here. Okay. N has dimensions 1 by 2, and P has dimensions 2 by 1. They're not the same. So it's an X. Now we want to multiply N and P. Is that possible though? That is actually possible. So row by column, row by column. So let's say this is N. It has to be in the correct order. So 1 times 2, and P is 2 by 1. Notice that the column of N and the row of P are the same, meaning that you can actually calculate it. You can move forward with the calculation. Now, when dealing with the outside parts, that will tell you the row and column of the product. So if we were actually to go about this calculation of N times P, the final answer would have a row of 1 and a column of 1. Okay? Alright, so let's move on. M squared, so M times M. That's possible because, again, it has the same column. And if you put M again here, so 2 by 2 on this side, just imagine it's here. You notice the 2 on the row and the 2 of the column are the same, so you can move on with the calculation. So N squared is not possible though, because you have 1 by 2 times 1 by 2. The 1 of the row is not the same as the 2 in the column, so you can't do that. Now m times n, m is 2 by 2, n is 1 by 2. The 2 here is not the same as the 1 here, so that is a no. However, n times m is possible because the 2 here and the 2 here are the same, so you have to be careful. It's all about the order in which it is given to you, okay? All right, so let's work out 1, 2 plus p, right? So p is 4 and 1. All we have to do is go in the correct order. So row and rows together, columns and columns together, right? So 1 plus 4 is 5, and then 2 plus 1 is 3. That's your answer. That's it. So let's work out p times n. So we have p, which is 4 and 1. N is 1 and 2. So we have a 1. So it's 2 by 1. So p is 2 by 1. N is 1 by 2. So the column of the first one is the same as the row of the second one. So we can proceed with this. So what we're going to do is row times column. So 4 times 1, and then 4 times 2. Because we don't have anything else in this row, it's just 4 on its own, right? Okay, and then we're going to do the same with the second row, so 1 times 1, and then the second row with the second column, so 1 times 2. And then you'll get 4, 8, 1, and 2. So that's your answer. Okay. So now I want to work out the inverse of m. So m times the inverse of m gives you the identity matrix. So identity matrix is a square, right? So what that means is that it has the same number of rows and columns. So that means 2 by 2, 3 by 3, 4 by 4, and so on, right? And it's equivalent to 1. So for example, when we deal with 3 times 1 over 3 is just 1, right? The 3 and the 3 cancel out. And 1 over 3 can also be written as 3 to the power of negative 1, okay? So it's the same as 1 divided by x. So the x can be written as, so this can also be written as x to the power of negative 1. But say x has the power of 2, right? So it's 1 divided by x squared. It's going to be the same thing, but you're going to place a negative there. So it's going to be x to the power of negative 2. That's it. Okay, so we have m, and we want to find the inverse of it. Negative 1 is placed right there. So what we're going to do is this right here. So let's break it down. First things first, you notice in the identity matrix that this diagonal, which is the most important right now. So starting from up here, these two are 1s, right? So the diagonal that's going from top to bottom is the dominant one, right? So that's where the 1s are and everything else is 0. Okay, so this dominant one that's going from up to down needs to switch. So the 3 goes up, the 2 goes down here. And then the other one where, it's a line that's going from the bottom to the top, what we're going to do is not switch them, but switch their signs. So it's positive first, so it becomes negative here, okay? But we're not done. After doing that, you're going to multiply it by its determinant. So that means 1 over 3 times 2, which is the dominant one, the one that's going from top to bottom, minus the one that's going from the diagonal that's going from bottom to top, which is 4 times 1. So 3 times 2 minus 4 times 1. That's just the rule that you should follow. So the 1, of course, just simply means that, okay, so instead of putting the division at the bottom here, we place a 1 because anything times 1 is itself. So that could be your final answer. So 3 times 2 is 6 minus 4. So 6 minus 4 is 2. So that's half. And you have your matrix. You can keep your answer like this, or you can do this and actually multiply each one by half. So 3 times half is 3 over 2. Half times negative 4 is negative 2. Half times negative 1 is negative half. Half times 2 is 1. So either one is correct. So that's what I'm saying by it's okay if you place the 1 there because it's the same thing, right? It's the same as doing this and then putting a division sign and then a 2, right? So let's move on. Describe fully the single transformation represented by this matrix. So when you look at this matrix, you should know that it is a rotation matrix, and it rotates at the origin, and it's a 90 degrees anti-clockwise or counterclockwise. So you notice that it's 3 marks, meaning that you should mention 3 things. Now this is something that you should memorize. I'll leave a link to the website that I found, and basically I suggest creating a worksheet, not a worksheet, but a single sheet where you have all the different transformations, the reflection, the rotation, and so on. So you'd know, like, okay, this means this means that, and of course with practice they do get easier, and it won't be as difficult. All right, or you can try, solving one. So you create a matrix of your own, say 1, 2, 3, 4, like 1, 2, 3, 4, and then we're gonna you can multiply it by this and see your results, see what happens, and then try to plot a graph. That's if like you actually forget how to do it. So you can create a graph right here, like a really quick sketch, and place them and see like, oh, what happened? Did we rotate? Did we do a reflection? What happened? And you notice if you go to the top, it says that the material that's allowed is tracing paper, and that is what you can use to find out how much did you rotate? Was it 90 degrees? Was it 180? Was it 270? And so on. Okay. All right. So let's move on to question 9. Okay. So find the equation of the straight line that is perpendicular, okay, to the line y is equal to half x plus 1 and passes through the point 1, 3. So this is in the form y is equal to mx plus b. M is the gradient, b is the y-intercept, okay? So when you say that the lines are perpendicular, it means that the gradient of this line and the gradient of the other line that you're trying to find, when multiplied, gives you -1. Okay, that's how we know they're perpendicular, right? So the gradient of the first one is half. So what would the gradient of the second one be? We're going to move the half to the other side, so it becomes division. So -1 divided by half will give you -2. So that's the m, or the gradient of the other line that we're trying to find. So y is equal to -2x plus b. Right, so let's try to find b. What we're going to do is substitute the values for 1 and 3. Right, so y is 3 and x is 1. So -2 times 1 is -2. We have the 3 right there. So we move -2 to the other side. We're going to do the opposite operation. So it becomes 3 plus 2 instead of 3 minus 2. So that is 5. So b is equal to 5. And there you go. That's your answer in the form of y is equal to mx plus b. All right, so the second part. Find the 3 inequalities, okay, not equations, that define the region R, okay? So we're trying to find R. Let's start with the first one. So here you notice that there's a line that's vertical, right? It's parallel to y, and it crosses the x-axis at 2. So that means it's x equal to 2, right? So no matter the value of y, x will always be 2. So think of opposites. So for example, if y is equal to 5, which is the second one, it's parallel to the x-axis, not the y-axis, and vice versa. So this would not be considered x is equal to 5, okay? So we have to be careful. Simply because it's parallel to the x-axis does not mean that it's x equal to. It is y, so it's the opposite. So you just have to be careful. Here, it crosses the x-axis, so it's x equal to. Here, it crosses the y-axis, so it's y equals to. All right, so let's find the third one. The third one is a linear equation, right? So it's going to be in the form of y is equal to mx plus b. So y-intercept in this case is 0, so b is 0. All right, we got that part. Okay, let's find m. So m is the gradient, like we said before, and the way to find gradient is rise over run. So we're going to take 2 points. So I chose 10 and 5, this point right here, and I chose 4 and 2. Doesn't matter which 2 points you use, as long as they are correct points that are actually on the line. So I'm going to label this one as point 2 and this is point 1. So just stay consistent, doesn't matter which one you choose, right? So y2, so the y value of the second point minus the y value of the first point, so 2 minus 5, over the x value of the second point minus the x value of the first point, so 4 minus 10. So that will give you -3 over -6 which is equal to half, right? So this is what you get. X equal 2, y equals 5, and y is equal to half x. But we're not done. We have to define the region R, and they ask for inequalities. So this at the end you're going to have to delete. So let's look at this. Here's R. Let's deal with x equals 2 first. You notice that R is to the right of this line, meaning that it's greater than 2. But it's also a solid line. It's not dashed. So that means it's greater than and or equal to 2, right? So it's a possibility that 2 could be an option as well, okay? So that's why you have greater than and equal to. So you have both signs. Now y is equal to 5. You notice that it's below the line, meaning it's less than 5, but it's also a solid line. So it's y is equal to less than or equal to 5. Okay, and finally the last one, r is above this line, so that means it's greater than and it's also solid. So you know it's greater than and equal to, or equal to, sorry, half x. So that would be your answer. You can get rid of these or you can just place them to the side somewhere. Just be careful to, not place them here because you don't want to lose these marks, okay? Now we want to find the point xy with integer coordinates inside the region R such that 3x plus 5y is 35. So integer coordinates meaning that they're whole numbers. We don't want any decimals or things like that. So one way of going about this, other than trial and error, is to solve for y. So make y the subject of the formula. So we're going to move the 3x to this side. So it was addition, so it's going to be subtraction here. Then divide the whole thing by 5. So 35 divided by 5, which is 7. And 3 divided by 5, I just kept it as it is. But you can keep it in decimal form as well. So what I did was try to find points and create the line. So when x is 0, okay, we give x the value of 0, y is 7. So we can plot that. Okay, I'm going to make a couple of those. Okay, so x is 0, right? And y is 7. So we go all the way up here. Okay, all right, so when x is 5, y is 4. So let's go to 5, and let's go up to 4. So right here. And finally, when x is 10, y is 1, right? So 10 times 3 over 5, okay? And then 7 minus that answer will give us 1. So let's go to that. So 10 and 1. We can create our line. Okay, so you notice it only meets R at one point that doesn't involve any decimals, because right here you'd have some decimal points. Here you'll have some sort of decimal points, but here it's exactly at 5 and 4. So that's your answer. And if you want to do something, you can always check. So 3x is 5, so 3 times 5 is 15. Y is 4, so 5 times 4 is 20. So 15 plus 20 does actually give you 35, so your answer is correct. Okay, so let's move on to question 10 and the last question. Okay, so we have this function f of x is equal to 2x minus 3, and g of x is equal to x squared plus 1. So they're trying to find, or they asked us to find so we're trying to find the answer of this composite function, okay? So instead of the x, they place the function g again. So what that means is when you have something like this, you're going to do this, all right? Let me just grab an arrow and explain this. Okay. You're going to take the second function and put it inside the first. So we're going to take g of x and put it inside g of x, if that makes any sense. So it looks something like this. So I'm going to just ignore the 2 for now and just keep it as x. So we have x here. Instead of keeping it as x, we're going to keep it as, we're going to substitute that x for the function. And we know the whole function is x squared plus 1. So we're just going to substitute that in place of x, okay? So we have x squared plus 1, open brackets, so it was placed in the previous spot of x, and then we're going to square it, and plus 1. So we're just going to continue everything as it is. So The most important thing is the substitution. Now we don't have to continue expanding this or anything like that because they already told us what x is. X is equal to 2. So we're going to substitute that there. So GG of 2, so we're going to have 2 squared, which is 4, plus 1 gives you 5. Square the whole thing, so 5 squared is 25, plus 1 is 26. Your final answer is 26, and that is it. I'd suggest doing a couple of these. Maybe try to fg of x, so put g inside of f, or gf of x, so putting f inside of g. So remember, it's the second one that goes inside of the first, okay? But in this case, it doesn't matter since they're both the same function. Okay, so find g open bracket x plus 2, giving your answer in the simplest form. So instead of it just being x, we're going to have x plus 2 in its place. So gx plus 2 is equal to this function right here. Instead of the x, we're going to put x plus 2. And then the whole thing squared plus 1. In this case, now we actually have to expand. So x plus 2 times x plus 2 plus 1. So expand the brackets, so x times x is x squared, x times 2 is 2x. Then 2 times x is 2x, 2 times 2 is 4, and then you have plus 1 right here. Now we're going to combine the like terms, so 2x and 2x gives you 4x, and then 4 plus 1 gives you 5. So this is your final answer, right, in its simplest form. If they didn't ask for the simplest form, you can actually just leave it like this as part of the first line, and you'd get the right answer, but they did specify to find the simplest form. Okay, so find x1 f of x is equal to 7. Okay, f of x is equal to 7, so you're going to do this. So we have 2x minus 3, and instead of f of x, we're going to place 7. We're going to solve for x now. So moving the negative 3 to the other side, we have 7 plus 3 instead of minus, so it becomes 10. Move the 2 to the other side, so it's going to be divided by 2. So x is equal to 10 divided by 2, which is 5, and that's your final answer. Now they asked us to find the inverse of the function f. So what we're going to do is substitute f of x for y. Okay, so we're going to place y instead. So y is equal to 2x minus 3. It means the exact same thing, no difference at all, right? So what we're going to do is switch the places of x and y. So x goes here, y goes here, okay? What we're going to do now is try to make y the subject of the formula. So move this 3 to this side, becomes x plus 3. Then we're going to get rid of this 2, so divide the whole thing by 2. There you go. That's the inverse of the function x, and that is x plus 3 over 2. Okay? So the last part of this paper, and we're finally free, we're going to calculate h, and then the value of x would be 0.3 in this case. So give your answer to 2 decimal places, so be sure to do that at the end. Okay? So what we're going to do is place that in our calculators. So 0.3 to the power of 0.3 is 0.697 and a whole bunch of numbers, right? But we only needed to do 2 decimal places, so the 7 is obviously greater than 5, so this 9 will go up. We can't really do anything but to change it into 70. So it's not 0.7, 0.70, okay? Gotta be careful so you can really get those 2 marks because we don't want to lose it over something very silly. Now find x1, h of x is equal to 256. So substitute that. So 256 is equal to x to the power of x. So what is x in this case? Now you notice that 256 or 256 is a whole number. So that means the numbers that create it must be whole too, since in part I, when using 0.3, we found out that x was like this non-ending decimal. So let's give it a try. 1 to the power of 1 is 1. 2 to the power of 2 is 4. 3 to the power of 3 is 27. 4 to the power of 4 is 256. There you go, we got it. This is the method that I would use, but I did find something else online. Credit to that person will be left in the description box. And this is the method they used. So they moved the x to this side, right? Square root of x is 256. Okay, so they said that since 256 is even, it's an even number, right? So they can divide by 2. So they're going to continue doing that until they cannot. And they said it's similar to finding n square roots, so n is just a variable, so it can be any number. So n square roots of a number given n. So for example, 256 divided by 2, 128. Divide that again by 2, divide by 2, divide by 2, and so on until we got to 1. Okay, so if you count the number of times 256 was divisible by 2, you see that it was 8. So you notice 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that means that it's 2 to the power of 8. Okay, so if you go 2 times 2 times 2 times 2 times 2 times 2, like 8 times, right? It will give you 256. And they said that 2 to the power of 8 is the same as 4 to the power of 4. And that's how they ended up concluding that x is equal to 4. So this is definitely something you can look into and try to figure out and see if it works with other numbers or not. But this is the method that I would normally use. It's just trial and error. And at the end it's only worth 1 mark. So even if you don't figure it out, that is totally okay. And yeah, so I hope you guys enjoyed this paper. I'm sorry it took a little extra time, but it's finally out. And thank you for watching till the end. If you find it helpful, give it a thumbs up. If you want, you can subscribe. If you don't have to, but it is quite helpful for me. And share it with any of your friends who might be struggling with math because, we're all here to learn at the end. We all make mistakes, even I make mistakes, and together we can, do even greater things, right? So I'll see you guys next time, and yeah, bye bye.